In this video we see a nice problem on the interval of convergence of this series. So in order to check so we have the series from 1 to infinity n times x to the power of n divided by 2 to the power of n, and we want to study the values of x for which this sum converges. It is the interval of convergence or radius of convergence. So what we have to do is take the limit of n growing to infinity of the ratio w n plus 1 over w, where wn is n x to the power of n divided by 2 to the power of n. So we take this limit as n goes to infinity of the ratio of wn plus 1 divided by wn, and this should be strictly less than 1. So it's the limit as n grows to infinity, n plus 1 x n plus 1 divided by 2 to the power of n plus 1 times 2 to the power of n over n x to the power of n. N plus 1 over n times 2 to the power of n divided by 2 to the power of n plus 1 times x to the power of n plus 1 over x to the power of n. We need to do a little bit of algebra here. 1 plus 1 over n, 2 to the power of n over 2 to the power of n times 2 times x to the power of n times x over x to the power of n. Now we simplify these terms here, the 2 to the power of n's and x to the power of n's, and we have the limit as n grows to infinity of 1 plus 1 over n x divided by 2. So this is the modulus of 1 plus 1 over n times the modulus of x divided by 2. So as n grows to infinity, this goes to 0, and you have the absolute value of x divided by 2. And this should be strictly less than 1. X strictly less than 2. So x is from minus 2 to 2. And this is the radius of convergence. Now we say, why not the minus 2 and 2? It is very simple. So let's go back to the sum, to the infinite series, and plug in n equals 2 to see what happens. X equals 2, sorry. So we have n times 2 to the power of n. So I put x equals 2 to the power of n over 2 to the power of n. So I have the sum from n equals 1 to infinity of n, which is adding up from 1 to 3 infinity. So the value of 2 does not suit me here. If I substitute x equals minus, so this is for x equals 2. For x minus 2, I rewrite the sum, the infinite series, minus 2 to the power of n divided by 2 to the power of n. So this is n times minus 1 to the power of n times 2 to the power of n divided by 2 to the power of n. So again, here is I have this alternating term here, -1 to the power of n. So if n is even number, this term becomes positive, and if n is an odd number, a negative to a raised to an odd power, it should be negative. So here again, this does not suit me. So the only values that I'm allowed to put are the values between -2 and 2. So assume that this is my interval, so I cannot put -2 and 2. I can only put these values here inside the 1D interval. It's a quite nice problem. I really like working with the infinite series, and finding the radius of convergence is quite a fun process to do.